Welcome back. We're going to take a look at exercise 10 in Creo Parametric 6.0. In this exercise, it's what I call the real world scenario. Now, there's no way to really make that unless you're truly working at a company, but this is as close as I could bring it, you might say, without making it too overly complex and too long. Because typically projects, especially in industry, can take a long time, especially if you're handed something that's halfway through or even beyond halfway. It's almost unknown sometimes how long it's going to take. It's very difficult to judge, especially depending upon the user. So what we're looking at here is an old speaker. It's like a Bluetooth MP3 player speaker, or whatever you want to think of it like. It's very tiny, actually. What you're going to do is you're going to get this, and then we're going to download it, and we're going to have to put in certain features. Like, for example, it has a hinge for this case that pops out, and you can wrap up your headphones and put it in there. Now, the hinge, you'll see inside that there's actually a hole and there's a post. The post doesn't exist. We have to put the post in. You can see it done there, but that's what it's going to look like. Also, this is the speaker or LCD screen, whatever you want to call it. I'm changing it now to a speaker because MP3 players have kind of gone the way of the dodo. Anyhow, so we need to build this, and that's attached to the circuit board that's inside here. Okay. Another thing that you're going to have to do, I'm going to go ahead and open this up. Actually, let's hide this part. Okay. And it's difficult to see. Let me lighten that up a bit. There we go. Now, what you can see in here, this is the battery cradle. That goes in there. Let me hide this part too. We're going to need to make this. This whole part here is going to come solid. We have to shell it out, put this lip on here. It's a 1/2 inch, I'm sorry, 50 thousandths thickness, and then the height is going to be 100 thousandths, and it's going to have 1 degree of draft. So we're going to have to learn how to put that in there. And then these, the cradle we're going to have to build. Now notice there's no straight edges anywhere. So to build this cradle might seem a little daunting at first to a new user, but I'm going to show you some tricks that make it actually really easy, where you're not having to measure anything, quite honestly. You're just drawing in the geometry off of the circuit board. So anyhow, and then you also have to get the battery, and you're going to have to make the battery. And I'm not going to make it in this video because we're getting into advanced things. And what I want you to do is actually build the battery, and that's on the Vertanu 1 webpage under part files, believe it or not. But when you click on here, you'll see E10 battery DRW. Now there's the parts that we're going to need. We're going to grab that in a second. But when you go to the E10 DRW, it's actually a drawing of the battery, so you have to recreate that, and that's in inches. Okay. I'm not going to do that, but you're going to need to do it. Those of you who are my students, model that up and put it in position. And actually in that battery cradle. So we see here the exercise 10 parts. What you're going to do is you're going to click on those parts. You're going to hit download. And you can just hit open wherever they are. And it's going to bring up Windows, and actually in this case Explorer. And you can actually see here, you can hit extract all. That's one method. I just usually just select all that, right click, copy, and then I'm going to go to my Creo folder that we started the first day of class. Remember, you could go in Documents and create your own folder, and then create a new folder. Just go to right click, go to New Folder. I'm going to call mine E10B because I already, so you can see the image up there, I already brought it up. And E10B, I'm going to double click, right click, and paste all the parts in there. And you can actually click on it and see that there's some things there. Now, it is a little confusing here. When I zip this all up, you'll see that there's a couple E10 assemblies. You actually just want the E10_ASM. You don't need these other ones that are there. Those are revisions and things, so don't worry about that. But I'm going to go ahead and close this up and restart Creo. Okay, so I restarted Creo from scratch. You didn't necessarily have to do that. I did it because I already had these parts up and I didn't want to have the finished parts show up. And you can see I have them extracted in my E10B folder. Yours could just say E10. It doesn't really matter. Now, what you want to do, Also, you don't usually want to open up the files from Explorer here. Sometimes with Creo, when you download, especially the student files, there's like Creo Simulate, there's a couple different applications, and it might actually launch into one of those other applications when you double click on it. So just be aware that you want to open them through this area here. You go to Open and find your Creo folder that you created, and there's my E10B. I'm going to click on it, and we just want the E10 ASM.ASM. You don't want the ASM_2 or the assembly one. There's a couple sub-assemblies in here that we don't want. So it's just this E10 ASM, hit open, and we could see the assembly here. It looks a little different. I changed the colors earlier, but we're going to go ahead and tinker with this. So we could turn off the planes actually and these other things. We don't need to see those. Also, this little ring, you could hide that. All right, now we're going to start off. And if you look at the training guide here, let's bring up the training guide. This is what you get. And this is on the second page of this. And let's see, it's page 95 of your training guide. I already downloaded it and I rotated it. I just went over here to rotate. This is in Firefox. All right, so we could see here, this is the instructions. And this is what I mean real world scenario. When I worked in industry, not only did I create redline markup drawings, I actually got them quite often from my manager. I used to work in a mold shop and I worked for an engineering firm. And basically, a manager knows what needs to be done. They talk to the salesman who talk to the customer most likely, and then they give you, here's the list of instructions. And they typically have a drawing, and it's like, oh, let's grab a drawing that has the most images on it, and let's start writing this in. And usually they take a red Sharpie or a red pen and they mark up just like this. This is actually better than what I would get typically. And they don't want to write a whole bunch of things down. Some of the expectation is that you might come back to them, ask them some more details as you need them. But you do need to extrapolate some things on your own. First of all, the AA battery, make the battery AA battery into the socket. We'll leave that for last because we don't have the cradle set up over here anyhow. So we'll leave that for a while. But we could made it actually onto this, but you're going to have to build that. I just showed that to you where you could get that drawing. Or what I tell my students sometimes, just take a battery, take a caliper or a scale and measure it. It's really easy, and then model it up. Okay, and so those are things you don't want to waste the time with talking to your manager if you can help it, because that only takes a few minutes to model something like that up. Now, as we look here, we could see this is a mixture of bottom up and top down. So the battery is bottom up because we're going to model that probably outside, bring it in. And then some of these other parts we have to model from scratch, and then there's some part editing too. So let's first try and get this LCD screen or speaker, whatever you want to call it nowadays, a Bluetooth speaker. I want to change the name of this eventually. And so you can see there's a lot of confusion over here on the left, and what it is, it's just sub-assemblies inside assemblies. And so I'm going to hit those little arrows up to simplify it a little bit. I'm going to go to Create. And then over here, I'm going to call this the, instead of LCD, I'm going to call it the speaker. And part solid, hit OK. And we're going to use copy from existing, inch-pound part, hit OK. And what I recommend doing here is go to default. And we discussed that before. Hit OK. Now you can see the speaker listed there. Hit the speaker and edit the speaker. Now there's the circuit board, and it's supposed to rest on the circuit board. And this you would find out typically, like the boss would say, hey, make sure you put that, that's going to be mounted onto the circuit board. So what we can do, we could select the circuit board and go to extrude, because we're going to extrude the part off of that. And now we want to steal the edges here. So I'm going to use the concentric circle and capture this inside edge, click, and drag it out a little bit. And don't touch the edges. That would make it line to line. It wouldn't fit very well in there. We're going to give a little offset here. Click, middle click 2 times. Now the hole, I bet you, is 2 inches in diameter. We're going to make this 1.95. So there's just a little bit of clearance in there so it could be assembled easily. Hit OK. Now as this extrudes up, we don't want it to extrude up like that. We want it to follow the contour of the outside surface, which looks like kind of like a bean shape. let's go over here to depth and change it to this little guy over here. Extrude up to selected surface. Now select this surface. Look at that, it conforms to that surface. Hit OK. Now, it's not in the print, but let's put a little chamfer on there. Just make it look nicer. Go to chamfer. You can set it to 0.05 D times D is good. Select this edge. And there we got a nice little broken edge. Okay, we're done with that part. We don't need to do anything more. So what you want to do is click on the very top of the model tree here, where it says E10, and click on the activate to get out of that. All right, so one down. Looking back at our instructions, that's done. Let's do this now. Create the boss that holds the earphone case. So really that boss is attached to this front cover, the front bezel. And these are not called front bezel, as you can see here. So what you do is you click on the part that you want to edit and just activate it from here. So make sure you click on the red beam and activate it. And it's going to give you this little message. It's because there's sub-assemblies in here. Go ahead and hit confirm. Okay, now zoom up to that area down below here. You see where I'm at? And there's a little flat face. Let's go ahead and select that flat face and go to extrude because we want our post to come off of that. Now we're not going to go into the engineering details of creating bosses and mushroom clips and all that stuff. That's for an engineering class, plastics engineering. I'm just showing the basics. Okay. All right. Now I'm going to go ahead and go to hidden line. And there we could actually see the hole that our post needs to go into. So use your circle again, and notice it's concentric circle that we're using. Click on this edge, drag it in a little bit, don't make it equal, have it spaced out a little bit, again for some clearance. Middle click 2 times, find that dimension, 0.12. So it's 0.120, it's actually 0.125 for the hole. So we're, again, giving a little bit of clearance. Hit OK. Rotate this, and it's going to be 0.2 for the height. Hit the green check. Let's go back to shade with edges, and there's our post. All right, 2 down. Let's go. Oh, we're done with that. So we could actually click on the top of the model tree and activate the model tree, so we're no longer in edit mode. Now the next one is actually adding the geometry on this part. So click on this part, and we're going to actually open it up separately from the assembly to work on it. Could we work on it in the assembly? Absolutely, but there's a lot of stuff in front of it that gets in the way, and I don't want to have to hide and then unhide them all. So it's just easier to click on the part and go to open, and it'll open it up, and it's outside of the assembly now. Look at that. Now we could do all the work we want on it. Let's go right away, click on this face, go to shell, and the shell thickness should be 0.1. Hit enter. Now we need to create that lip around here. So go to extrude, select this face right here. And we're going to go ahead and offset this geometry. So we could go to project first of all. Select the inner edge. First, go over here to chain. Select this inner edge. See, it's the second edge. And then these 2 edges. And then hit yes. It's going to create a loop. We got a nice sketch there. Let's do that again. Let's this time though, let's do an offset. And we'll do chain. Select that curve there. Select this curve here. And let's, I'm going to cancel out. I should have zoomed out earlier. It won't let me do that just yet. So let's zoom out here and make sure the whole thing's in there. Let's try that again. We're still in chain. Select this edge here, and then hold control, select that inner edge. Okay, this is what I was looking for, the arrow. Which direction was pointed? Because that will tell us whether we have to go plus or minus. In this case, it's going the wrong direction, so can't really flip it. I don't think so, no. So we have to type in minus 0.05. Hit the green check. All right, now it made it a collection of polygons. And do you want polygons? Probably not. And the problem, what we are experiencing here, is that we went ahead and selected the curves that we copied over versus the actual edge of the model. So hit close here, and let's hit undo. Get rid of that. So here's a better option. Let's go now to offset, chain, and select the outer edge instead. Now I'm going to hold Control, select that, and it looped around for us. I'm going to go ahead and hit accept, and it's going to give us, you want to create a loop? Yes. Yeah. All right. Again, we can see the arrows in. So in this case, we do want to go in because we're starting from the outside versus last time we started from the inside. So this is not going to be a negative number. It's just going to be 0.05. Enter. And look at that. It's not a polyline. Why wouldn't you want polylines? Well, sometimes some old machines like polylines, whereas they don't like these freeform curves, which are called splines. Especially older machines pre-1999, like 1999 and older. Typically, those machines, got to be careful. Some of them like polylines, which are a collection of a bunch of little arcs or lines. It can't handle spline geometry. So any new machine pretty much these days can handle it. But just be aware that might be an answer for you if you ever want to, working with someone who has an old machine. Okay, I'm going to hit OK. Now we can see it's immediately trying to extrude it. Let's change that extrusion depth to 0.1, hit enter, but we're not done yet. Go to options and add a taper, and the instructions were to add 1 degree. So we have the taper here. Now it's kind of hard to see sometimes with the preview. And so what I do, see the little ball, I zoom up to the little ball, and I try and align myself to it. Let's see, wherever it might be. And now I clicked on it, and now we can see that's going the wrong way. So we want it, look at that, it's flaring out. I'm holding on to that little ball and I'm dragging it. And we actually want it to be 1 degree. There we go. Okay. So that's one way you could see it, especially with 1 degree. 1 degree of draft is very difficult to see. Quite honestly, it would be much higher than that, most likely. Hit OK. Now we want to put in the cradle for the battery. And it's not a single sharp straight line on here really, unless you're looking from the side. So that doesn't no good. So what we're going to do is let's go up here, click on this, and go back to the E10 assembly. And let's hide this part. Click on the red part, go to hide. And there's our cradle. In fact, if we want, we could hide this just so you can see what we're dealing with. Okay, so we have our all of our stuff on our circuit board, but here is the cradle. And see these red bars are what we want to align to. So it cradles the battery on both sides so it doesn't wiggle around. So let's bring back that part. I believe it's the original 12. Yeah, original 12. Show it. We don't need the other original one there. Okay, select the floor of that part. Go to extrude. Now, go to wireframe or hinge line. Zoom up to where the battery cradle is. This is the battery cradle. Okay, if you're looking at the whole thing's upside down, to be honest. But what we want to do, look at, there's fillets on here, and we don't want to, it's going to make it difficult to actually draw this geometry off those fillets. So go to references and select this outer edge right here and this outer edge here. And you'll see now we have a theoretical sharp corner to snap to for that. Let's do the same at the bottom here. This outer edge here and this edge here. And then hit close. Now we could go to the corner rectangle, zoom up to this theoretical sharp corner that we just made with the references, click, drag this across just like that. Now zoom out and let's get this one. Click here. And now what we're looking for on this edge is the equal symbol. That means we're making it equal to the other one, as long as it's small. Actually, let's try and zoom out so you can see this. There we go. Click, middle click, and then this one controls the wall thickness. Now, plastics engineering, I know I said this isn't a class about it, but we want it to be somewhat realistic. On a plastic part like this, there's the 60% rule. What you do is you take the ribs, internal ribs should be no more than 60%, the thickness of the actual shell of the original part. And the reason for this, if they're the same thickness or bigger, you get sink marks because the plastic shrinks because there's those large volumes of plastic. And then you get a wobbly part on the underside surface. So we don't want that. So the overall part thickness was 100 thousandths, 0.1. So we'll make it 0.06. So double click here, 0.06, hit enter, hit OK. Now let's shade this because it's difficult to ascertain what we're looking at. All right. Now we can see they're going in the wrong direction, so we can flip that. And what we've discovered here is what I did in last lesson again. And this is very common. Could happen to anyone, even a person who's been using it for 20 plus years. Okay. What I neglected to do is edit the part. And so there is a time-dependent feature, was what they call it in some systems, and essentially it will let you trim and cut other parts around it if you're in the edit of the assembly. But be warned, if you ever go to shade it and you don't see it, it's like gives you a wireframe like this, you forgot to edit the part most likely. So cancel out of here, hit yes. Now we have to, let's bring all this stuff up. It's a little confusing. All right, let's click on this part and edit it. I think actually had it on edit, and I might have turned it off actually, yeah. Oh, you know what, when I open the part in isolated, I think, maybe, I don't know. Anyhow, I screwed up. So, learn from that. That there is a priceless lesson. It's gonna happen to all of you. It happens to me on a regular basis with this. Okay, now select this face, go to extrude, and let's just repeat that again. Let's go to wireframe. And remember, we use references. Select this edge here, that edge, and then the one down here. That gives us our theoretical sharp corners. The rectangle, you can get that corner now. Click here, and we'll start from this corner instead, just for the heck of it. To there. Oh, and I forgot to make them equal. That's okay. Go up here to equal, select this line to that line. Now they're both equal. And now we could double click on this and a middle click 2 times, then double click on it. And let's do our 60% rule. Hit OK. Now let's shade it. Let's see what color. Hopefully it's opaque. Yes, we've got it. So there you get an excellent example from my blunder on what not to do. So make sure you edit those parts. That's why it's so important to get that green star over them. All right, now we want to extrude this. So let's go up to surface or edge. So click on this. Now we're going from the floor up. And if you look underneath here, look at that is the battery cradle right there. See the arc? And it goes down. You want to capture one of the bottom edges of it. And so it goes up to it and it touches it. Goes no further. Look at that. We didn't even have to measure it. You could have gone and measured it. But remember, if a change ever comes down and they say, you know what, there's not enough room in here, let's make it a little bit bigger, you won't have to worry about this because it will always go up to that surface and make a nice tight contact for that cradle. Hit OK. Now let's go ahead and rotate this around. There they are. Let's select this face right here. Go to extrude. Now we have to make the cutout scallop for the battery. So zoom up. We went normal 2, and you could see right here, there's the scallop for the battery. Let's use our circle tool again. Drag that in and just click on that edge again to match it. Oops. You know what? Let's not use that one. Let's use the center point. So highlight that edge, get to the center point, click and drag this out to the edge. Middle click. I think we could have used concentric circle. I probably just shouldn't have clicked on that edge. I don't know. Anyhow, now that we have that, feel free, if you guys try it, put down in the comments. Anytime you see me make a mistake or something, feel free to put it in the comments. I appreciate it. It helps others. I'm not perfect. Hit OK. All right, now I'm going to flip this, and we have to select Remove Material. Now, again, we want it to go up to a surface or edge, and we probably want it to stop right about there. Boom, right through. Nice preview, hit the green check. Now, we could go ahead and edit the assembly. All right, and look at that, we have our cradle. Now, if you want to put the fillets on to match the other ones, that's fine. I don't require it. You've done enough. This is pretty complex stuff, what we're doing here. It becomes second nature, though, once you've been using the software for a while. And it's quite powerful, as you can see. Pretty neat, too. Okay, I'm going to go ahead and model that battery because I just want to finish this to show you guys. So I'm going to hide this, and I'll put it in this cradle, but let's go now to New, Part, and I'm going to call it Battery. I'll actually call it double A underscore battery. All right, let's take a look at what we need here, just to show you how easy it is, and I still expect my students to make this. Okay, there's the AA battery. Remember, it was under the part files, and E10 battery DRW, it stands for drawing. Okay, there it is. It's 2.60 and 2.10 with the tip on it. The diameter, 0.6, all right? And there's more details on here than you quite honestly really need. But, so it's 100 thousandths little tab, and the diameter there is 0.477. So let's model this up. So I'm going to go to the front, go to Extrude, Circle, and then let's go ahead and just match that drawing, 0.6. We'll refit it, squeeze all that stuff down in there a little bit better. Okay, now we could go ahead and hit OK. And the extrusion was 2.06, if I recall. Hit Enter. And let's refit. Don't forget to refit. Select this face here, go to Extrude. Let's put the little boss on the top. And I think that was like some weird, like 0.447 or something. Oh, that's really big. Oh, that was for the bottom. This one's probably 0.2. All right, hit OK. And it's only 0.1 in height. And if you want, you could dress it up a little bit, put some rounds on it. I'm not going to put all those details that you saw on it. Okay, now I'm going to go back to the assembly, and we could go to Assemble, and it's in session. I didn't save it yet, so it's in session. You just find the AA battery in there. There it is, AA battery. And there we go. Okay, let's get it over there. We could rotate it. I didn't put positive or negative down on this, but let's go ahead and we'll mate this surface to this red surface here. And we can drag that down. We could actually then, no placement here, new constraint, select this face to that contact right there. And there we go. It's in there nice and tight. If you want, you could change the color. I'll make it blue. Oh, we can make it copper. All right, and select the part, middle click, and there's your battery. Now let's go ahead and bring everything back. So the original here, you can tell which ones are hidden by the grayed out. Go to Show, and then the original 36, let's show that. And let's go to an isometric view. Well, oh, that's fine. There's not actually an isometric view in there, but because this is imported. But we're going to go and just rotate it like so, and let's explode it. Let's go to Edit Position, select this face here, grab that arrow, drag it forward, select that face there, drag it backwards, select this face, drag that forward, drag this one forward. We can rotate it, get that battery backwards. Maybe the circuit board will move a little bit further away. Give some clearance. Okay, and that completes that exercise. Now, as far as your lab, Now the lab, now they're starting to get tough, okay? So I'm not going to build this whole one because this one takes a long time. And at this point, we're near the end of the semester. Next week, we're going to cover sheet metal, okay? And then we have a couple other little things we're going to talk about. But these labs at the end are pretty tough. They're good labs for you. I'll admit, there's a couple dimensions that might be missing. If there is a dimension or two, I'll try and call it out on the video if I get that far. If not, just guesstimate. What typically you could do, you could print it out. You see the dimensions on there, take a scale, and then calculate the scale percentage of that. Like figure out how much it should be just using the scale. Back in before CAD, like in the pre-1970s, that's how they used to do it on drawings. They would actually just measure with scales and calipers and things, and then you could adjust it. So if it's to scale, the print is to scale, you measure something, that's actually the true measurement. If it's half scale, that's half of it, so you just double it. All right, so let's take a look at that. In the training guide, you'll see the next page, and we're on page 96, is this. It looks a lot more challenging than it really is. It's all prismatic geometry, i.e. it's arcs and lines and circles. There's nothing freeform about this. But let's take a look at it. There's a lot to look at here. And like I said, there's a couple areas that, like that diameter, that hole I'm missing. Oh no, there it is. Maybe I fixed it. I can't remember. But you might find a couple dimensions that are difficult to find. Most likely they are in there, or like this, when I have 0.060 times 1. And when you see DP, that means that times 1, it's 1 inch deep. Okay, so just be aware. There's things like that where I've had this. I think there might only be one dimension, if I recall correctly, that might be missing on here. And it's somewhat easy to find once we get there. But all right, the overall is 4 inches by 1.5 by 2.5. So let's get that started. Go to New Part, and this is Lab 11C. So L11C. You could draw this from whatever perspective you want. I'm going to actually start on the top. And I'm going to go to Extrude. I'm going to use the center rectangle. Draw that out. And it's 2.5 wide by 4. Refit. Squeeze those guys in there a little bit better, and we'll refit again. Okay, hit all right, or okay. And now it's 1.5 in height. I believe so, yep. And let's go to standard orientation, which is isometric basically on mine. Okay, there's that like chamfer in the front. And so what we're looking at with that, here it is, 45 degrees by 1 inch. So go to chamfer. So we could do 45 by 1. Select that front edge, and there it is. Look at that. Probably a lot easier than you thought it was going to be. All right, now let's get some of these other things here. All right, not ready to shell yet. You want to shell after you get most of the fillets in. Okay, so what we see here, we've got some radiuses, 0.375 on these two edges. So round, 0.375. Select this edge here and that edge, and apply. Okay, moving along here. And remember, try and go with the largest rounds first. So we got those are the largest, and then there's some smaller ones on the front and sides. So radius of 0.125 there, and just make sure that that's consistent. That's where it might not be the best in this detail. 0.125 there, so that's on the front. And I think we're good. and says radius 0.125 upper corners. So I think we're good with going 0.125 with that. So let's go round 0.125, select this edge here, this edge here, and these edges here and here. Okay, once you get the rounds on there, before you start cutting any holes in, this is the time probably to shell, because if you look at it, there's really no other features. There's a recess at the top, but the recess actually, if you look at the print, it actually comes after it's been shelled. So let's take a look at the shell. Now the typical wall thickness, that's what I usually put in here. 30 thousandths for the recess. There we go, typical wall, 0.06. So flip this around, shell, 0.06, and select this face to open up and hit the green check. All right, let's get some of the interior parts here. Now we have some ribs, and there's a boss in the center. So I'm going to zoom up. And the detail on the boss is 0.125, and that's actually the top boss. The base is 0.25 diameter, 2 degrees of draft. And then the height right here is, it appears, before that post goes in, is 0.560 off the bottom edge. Okay, so what we can do with that, you could select this face and go to plane, drag that up, and what was it again? 0.56. Hit OK. Now click on that and go to sketch. Flipped it around. That's okay. We could go over here to, let's see, top, bottom. We want bottom. Okay. Now we have to locate where that's going to go. It's a circle, 0.25, and it's 1.5 and dead center there of 1.25. So let's go with the center line. And then we'll go to the circle tool, and on that center line, right about here somewhere, draw. Darn it, I missed it. Click, click, 0.25 diameter, and 1.5 from the back edge. So we're going to go to dimension that. So from here to center, 1.5. Okay, that located it. Hit OK, and we can just extrude that. Now, actually, I could have extruded off the bottom surface. I was thinking of the rib tool, which we didn't need just yet. I'm going to go to extrude and hit OK. In fact, actually, I could put the draft on later. Yeah, let's cancel that. I got an idea. That this is a good plane that we could use later for the, let's delete this circle. Or we could actually keep it there. Actually, yeah, we could keep it there. We could select the bottom face, go to extrude, and then we just go to circle, highlight that, and draw the same size circle. Since it's already placed and positioned, so it's almost considered a little sloppy here, so your boss may not like this. I would think it was okay because you still have control over it on that plane. So, but anyhow, it's supposed to go, we could actually have it go up to the plane, I suppose. That would be good. So we could select this and then have it go up to the datum, because we know the datum's the height that we want. And this is a completely different way. I've never modeled this area this way before, so just be aware. Okay, and I'm going to go to options and taper, and 2 degrees. All right. And we could hide that edge there. We could just click on that, hide that. Now a post goes on there. Let's go select that face, start sketch. And this is 0.125. It's in the center. Wake that center up. 0.125. And then, okay. And let's check out the height for that. That is 0.125. See right there? Follow the area. And that's what it's set to by default. And I don't specify draft on there. We probably could, but I didn't say to put it on, I don't think, so don't worry about it. Okay, now the ribs. And since we have this structure here, we can select this face, start a sketch, and add our ribs. So the ribs are nothing more than, let's first add center lines, or one center line across there, and then go to the line tool. And did we need the center line? We could have gotten away without it, but we'll go ahead and put those in. Oops, forgot one more, right over here. Okay, so there's those 3, and you don't have to dimension them because they're just an alignment, they're just as a reference. Now we hit OK, and we could go now to the rib tool. And again, I love Creo's rib capabilities. They're just outstanding. Okay, so we see here the ribs are 0.06 thick, 1 degree of draft, 3 places. And there are fillets called out here. I think they're 30 thousandths. I can't remember. Thought I called them out somewhere on this print. Rather than look all over for them, I'm going to just go ahead and put them in so you can see how that's done. So let's put in 0.06, 1 degree of draft. And then let's see, just make sure that's 1. Yep. Almost looks like 0.1, but I think we're okay. And then we'll go ahead and round internal edges with that. And they're 0.03. Beautiful. Hit the green check. And then there is a round that goes in there right here. And it should be the same 0.03. And then here. And then here as well. I might have even been able to put the boss in there as a circle. Not sure though. I haven't tried it. Feel free to try it if you like. Okay, so we have the structural rib. Moving along here. Now we have this little window on the top, and it's position 1.5. It's 1 inch by 1 inch, and it's a recess of 30 thousandths. So select that face, go to extrude. We could use the center rectangle. So 1 by 1. And position again, let's verify that. 1.5 off the back edge. I brought it to center, so we could have just went straight off the center there without that. That's okay. All right, I wasn't sure. Let's go to sketch. Fillet. Now you could put the fillets in as features or a sketch here. I'm going to go to the fillet feature. See, notice there's several different types: circular trim, circular, elliptical trim. We're going to go circular fillet. And select this edge here to this edge. There to there. Here to here. And here to here. Now let's verify what those are, and we'll make them all equal. So 0.2, 4 places. So let's middle click 2 times, change this one to 0.2, and I'll go to equal and just proceed to select all of those. There we go. Hit OK. Now this gets cut, but only 0.03 deep. And now we can select that face, go to extrude, and draw our circle in the middle. And I have the diameter for that. Yep, 1/2 inch through. Okay, flip that, make sure it's through all, and apply. All right, we're getting there. Now, this little window for the LCD screen, select this face, go to extrude. Now, this one is a little tricky, I think. Let's see, because we're looking here, this is an auxiliary view pulled off of that side view. So we see that there's the boxes. There's an inside and an outside offset for a lens, and there's a recess. You can see the recess right over here. But what we're looking at in this area here, let's see, we have 0.714 through, and by 1.8, and to locate that, let's see, it's 0.25 off the edge, and what are we missing here? This might be the dimension that I'm missing to locate where that goes. It looks like it follows that, but let's just try and put it in, and then we'll look on the drawing. Maybe we'll, oh, I bet you, I think I just found it. Maybe I do have all the dimensions on here. Oh yeah, there it is. Theoretical sharp corner. Oh gosh, that would indicate we'd have to put the fillet in beforehand or do a section and make a TSC. Okay, so it's a 1/4 inch off that edge. All right, so select, we already select that face. Let's go to the rectangle tool, get right up there, draw this out, and it's 1.8. And then we have 7.714. And then it's actually dimensioned off this edge, which we don't need it because it's centered. You don't need to put that one in. All right. Now the location was off the theoretical sharp corner, so I guess I should have put that fillet in later. We should be able to still calculate that though. Let's see if we extended that out. We could draw. We could take this. Yeah, we should be able to do this. I'm going to take that. I'm going to project that edge. Or draw over it. Here, let's just draw over it. There we go. And then we should be able to, if I go, let's see here. Go to sketch view there. I should show that more often. I forget about sketch view all the time. If you ever rotate, the sketch view tool is just awesome. It brings you back to the orientation, especially on something like this that's not planar to front, top, or right. Okay, so there's that. Now, in theory, let's see if we could do a projection of this. I think this will give us a theoretical sharp corner. Let's see. No, it's not. Okay. All right. It's just a geometry thing, a trig actually. I can't think of it right now, but I will later. And in class, I'll talk about it. Maybe the next time I make this video, I'll do it. I could have left that fillet off, but basically, I'm just going to go ahead, since I'm the designer of this part, and I think that was a stupid move on my part to go with the theoretical sharp corner there. Although, if I were to cut it from the side, we'd be able to get it. You know, actually, I'm going to go ahead and cut this right now, but I think I got a better way. I could have cut it from the side, and that way I could capture the theoretical sharp corner easier. There probably is a way here, definitely mathematically, but I don't want to waste your time as I tinker with this. So I'm going to pause for a second. Okay, I figured out a way to do it. Now, there's probably a dozen ways to do this, including mathematically. I'm going to do it using the geometry on the screen. Now, the problem is we were trying to get this 0.25 to what's the theoretical sharp corner because on the print, as you could see, to bring that up, right there is the front corner of that model right there, and it's pre-fillet, and it shows the theoretical sharp corner based off of that. And that's where the base of this profile starts. Actually, for this first profile. So here's what I ended up doing. Okay, to get that, let me just go ahead and hit OK here. All right. Now what I did, I took the, let me hide this one here, just so you can see this better. I went into the right plane, which intersects right through the center of the model. And let me show you where that is. So see the green plane right there? And I started to sketch on it. And I went ahead and I took the line tool, and on this bottom edge, drew up a line like that. And then off this edge, drew a line and connected it. Middle click. Leave that as a line, but this one you could go ahead and click on in terms of construction. Now when you hit OK, you now have a reference. So when you start this model, you start a sketch on this surface. What you do is you take the center line and find that point. See right there, there it is, the reference. And draw a horizontal center line. And then you could go ahead and dimension between that and the opening. So anyway, there's an additional offset on this. I'm not going to go ahead and do it. This is about as far as I'm going to go with this model, but just be aware that's a little trick without having to calculate it mathematically, which isn't a big deal. But if you want to use the CAD system, there you go, there's a little trick. And if you have a different way, by all means, below, share it with us. But this one I just thought off the cuff. And that, then there's some other features like little cutouts and things like that. I'm going to leave it up to the students to complete those things on their own. That completes this exercise.